Welcome, this is Michael Manner with Acme Brick. I want to introduce George Campbell. We're going to quiz him with a few questions about the JC Steele equipment. George, what's a good thing to look for every day when we operate a Pugmill?
Well, when you first get here to the plant, before you start up, you want to check your oil level in your thrust pot, and you want to have oil right here halfway up your sight glass. Now in these thrust pots you want to use Lubrication number 8, and it's a different oil than what you would use in your gearbox. And you want to do this while it's at rest. Right now the machine is running, so it won't be a good time to check it accurately. The other thing, if we want to walk down here to the sight glass on the extruder, or I'm sorry, the Pugmill. Right here is your magnetic filter, but you also have a sight glass for your gearbox oil, and this takes 220 oil. One thing that we recommend is that once a month you take this magnetic filter out and clean it, and it'll also let you see if you have any big pieces of material such as metal. Might be an indicator of a problem inside your gearbox.
How often should we change our filters?
Usually there's a gauge on the filters that'll be a red and a green. If it's in the green, you're still good. If it's red, then it's time to change it.
How do we know if it's oiling real good?
There's sight glasses, and these sight glasses here will show you oil flowing through them. Sometimes it's good to have a flashlight. Here I'm using my phone, and put a little light behind it, you can see the stream of oil, so that's what you want to see. Now a lot of times what I see is people will paint over top of these, and then you can't see the oil flow, or they'll be stained, but these glasses are pretty good. But you've got the 3 here, you've got 2 here, you've also got 3 back here. And basically what the ones on the front and the back go to a bearing, so this sight glass is feeding oil down to your pulley shaft bearing on the front. You also have one in the rear. This one is coming to your intermediate shaft, and then this one comes down to your main pug shaft in the front. And you'll also see it in the rear as well. Mike, here's a chart of the 90 BD pug sealer lubrication chart. One thing that people overlook a lot of times is this pulley hub and pulley shaft bearing that needs to be greased every 40 hours. And why they overlook it is because you have to lock out the machine, remove the guard, and grease it, because it's actually spinning on the pulley hub. You can't run a remote line to it. But they recommend you do that every 40 hours.
Are there other points that we would forget to grease on this machine?
Well, you've got an automatic greasing system, so your extruder and your pug sealer are greased automatically. If you don't have an automatic greasing system, normally you'll have 2 grease certs here that will grease your labyrinth seal or your dirt seal in the rear of your Pugmill. And that labyrinth seal purges any dirt out of that seal from the back side of your pug. Along with your rear knife, keeping that clean will save your shaft from excess wear or premature failure.
So a rear knife is critical?
That's very critical, and it's one of the most overlooked because it keeps that rear of the shaft clean and the dirt from building up and actually wearing down on your shaft.
While we're talking about pug knives, let's just go ahead and talk about the rest of the Pugmill.
All right. Here in the Pugmill, all your knives are the same except for the one in the very back and the one in the very front. Now, inside, your knives need to be pitched 1/8 of an inch to the rear. So if I had a square up here on my pug tub and I had it resting against the knife, it needs to be kicked back to the rear, the leading edge, just a little bit. And I think of it as the knife spins forward, that it's reaching to the rear, grabbing material and pulling it toward the front.
What's the maximum pitch we can use?
JC Steele recommends 1/8 of an inch off a square. Depending on your material, you may find it to be a little less or a little more. But if you've got even material all the way across your pug tub, that's what you want to see. And you want to see about 4 inches of knife sticking up out of the material. If you have more knife than that, then your tub is probably running too low, which could create a problem with vacuum perhaps. If you have more material and your pug knives, you can't see your pug knives, then you're probably not mixing your material as good as you should be.
You did mention the front knife's different than the back knife and all the others. What's the deal on that?
The front knife is a continuation of your sealing auger flight. And since we're talking about the sealing auger, it is possible to get your sealing auger installed 180 degrees out, and that creates a problem for some people. So when you install your sealing auger, you want to make sure that the edge of the flight on the sealing auger comes right up to that front knife. And if you have them right like that, then you know you're good. If your flight is down here and your front knife is here, then you've got them spun 180 degrees out, and that could be a reason that you're having an issue. It's easy to overlook, especially if you've got someone that hasn't done them very often before. Mike, since we're here at the Pugmill, tell us about the safety system you have set up here.
Well, what we do is we've got everything bolted down to where they cannot come up. There'll be no entry into a Pugmill to touch a knife, get anywhere close. But we also have what's a magnetic lock. So if these things, if a bolt breaks, if the clay pushes, if it rips anything out, and they break the sensor, we shut down. It shuts the machine down automatically. It's just another safeguard to make sure something doesn't happen.
Good, good. Well, since we're here, I was going to talk a little bit about your sealing auger case. This is a renewable sealing auger case, which means you can buy liners and bolt them into the case itself. Some of the older ones were designed that didn't have that, and you just had to replace the whole case itself. But inside here you have your sealing auger. Then as you move forward on the shaft, you have your sealing core. The shredder knives bolt into the core, and then along the outside perimeter is the sealing die and the sealing die retaining ring that holds the die in place.
I've got a question on the vacuum chamber. We've got a lot of people I see with a regular light and then an LED light. Is there a preference to what we should use and why?
Well, a lot of times the LED light won't get warm enough to evaporate the moisture off of the glass. So you want to have a light that throws out a little bit of heat. And I see you've got one here, Mike. And this looks like an LED type. It's not real warm, but then this light here is quite warm. You can feel the heat, and there's no moisture at all on the windows of this vacuum chamber, and you can see down inside it very easily. So inside your vacuum chamber, you can see the material coming through the shredder knives, and you want to shred that material up so that the vacuum system can pull as much air as possible out of your raw material. That will make the best brick possible. If you have a vacuum leak, you want to look for that leak and try to correct it, seal it off as best as you can. But you can also see at the time that ring right above your shredder knives, that's your sealing die retaining ring, and that one's in pretty good shape. Now if you've got a sharp edge on that, it could be an indicator that in the past maybe your sealing die had worn and the material started to eat into your sealing die retaining ring. Also down in your vacuum chamber, you can see your feed roll shaft. You can also see your extruder augers if you don't have a lot of material on them. JC Steele recommends that you run your augers full. That's the most efficient way to run it. But speaking of the feed roll shaft, Mike, one thing that a lot of people overlook is the shoes and the swipes. And the ones in the front will wear the most because that's where all the clay is being pushed to, all the pressure. And it's a good idea just to check those out whenever you have some downtime or you're changing augers to make sure that those aren't getting worn excessively.
What exactly do they do? Do they really provide any benefit?
Oh, you'd be surprised if you ever have one of these shear pins break and your feed roll shaft stop. More than likely your vacuum chamber is going to fill up. I have seen where people have ran without the feed roll shaft, but they have to turn the feed way down and run much slower. That feed roll shaft pushes that material back into your augers and helps it to push the material out of your barrel.
Okay, I got another question on the. We always have an operator at a lot of plants that just stands up here. I know he's standing up here so the vacuum chamber doesn't fill up. Is there a way of preventing that?
Yeah, Mike, there's a vacuum chamber level sensor. That's what you see here. It goes into the vacuum chamber, and if the material level reaches a level and touches that sensor, it will shut the machine down. If you don't have one of those, it's possible that your vacuum chamber may bridge over with material and it'll fill up, or I've even seen it come up and fill up to the very top of the lid and actually break the windows out. So you want to either have a person here paying close attention to it, or if you have this device here, it can save you a lot of heartache. One of the things I saw, Mike, that you do have that I wanted to point out was you've got a valve here, and this valve open is pulling vacuum through your lines out of your pump. Now if you ever had a vacuum leak, and I'm sure a lot of people have, one thing you can do is you can shut this valve and isolate your lines away from your vacuum chamber. So if you turn this off and you check it, you should, and your pump is working right and you have no leaks on your gauge, you should show a very good vacuum. Now if you don't have a good vacuum, then you know you may have a leak somewhere in a joint, or maybe even in your filter, or anywhere from here back. Another thing I noticed, Mike, is that you have these T-ways, which it's a good thing. If you do have a vacuum problem and you're having trouble figuring out what it is, you can open up a T-way and look down your lines and see if there's an obstruction or a clog. If you just have a line that comes up with a curve 90, the material may be clogged up right here after the curve and you may never see it. So being able to open that up to inspect it is a really good thing to have.
George, how often should we worry about our vacuum filter?
Most people will change their vacuum filter inside this canister once a day. I see you've got the gauges up there, and that will tell you a pressure differential between the inlet side and the outlet side. So if your filter is clogged, you'll have a larger differential between the two gauges. But it's a good rule of thumb that, you know, in the morning or at the end of the shift, just to go ahead and change it out, and so you'll have a fresh one for the day. Also, it's a good idea to have a gauge on your vacuum chamber itself, as you see here. That way, like we were talking earlier about isolating part of the system, you can see what kind of a vacuum you have here at the vacuum chamber. Here we have our water shroud. This is where the raw material from grinding is entered into the system. You also can see that recycled material from the setting machine, maybe the trimmings from the velour wires, are coming back around into the system. Here is the water sprayers, the water nozzles, and you'll always want to make sure your nozzles are spraying and the water is help me with that word. Atomizing with the clay particles, so it's mixing better. You don't want to have just a stream of water being sprayed into your clay. You want to have a good mix of the water and the material together. Here you can see the level of material in the tub. It's quite full, but that's good because you can still see the knives mixing, and it's mixing the return material with the water and the clay coming from grinding. You want to talk about your
Yeah, we do keep a safety gate over all these. We don't actually lay it over because we have material entering into the jumbo. It is a little different than the pug underneath. We kind of have a more unique situation where we're double pugging. We're getting a lot more mix. We start mixing with our water and anything we're adding into the body back here, and it goes through the whole entire system. Also, like I say, as long as we're talking about guarding, we also guard between all of our pulley shafts, all of the hubs. We put large gates on there. We do keep locks on everything to keep people from accidentally entering into it or just getting complacent in their job and just kind of drifting off into there. This stops all that. So this is another thing we try to prevent anybody from being able to get into anything and get hurt accidentally.
very good.
George, I came in the plant the other day and I had this smell like somebody had been, their brakes were just smelling up the whole plant, but nobody had been driving in here. What could that have been?
Oh, it could be your clutch on your back here on your pulley shift. If you don't have the proper air pressure going to that clutch to engage that disc, it'll slip and it'll smell like hot brakes burning. The other thing that you may want to look at too is if your quick release valves aren't releasing the air quickly. You should, when you disengage the clutch, you should hear a quick hit of air coming out of that. If it's slow, it may be leaking off slow and not disengaging that very quickly. Now, when we were talking about air pressure, they recommend that you have at least 90 psi coming to your clutch. So if you're having problems or air leaks somewhere else in the plant and your machine's not getting enough air, that could be causing it to slip.
That's good to know. George, I noticed the guys in the morning before they start up, they'll always come back over here and look around. I really don't know what they're doing. What could they be doing?
Well, here on your thrust bearing, when the machine is at rest, you want to check your sight glass. And you want to make sure that you have a proper amount of lubricate number 8 in the sight glass, halfway up the glass. Now that's a different oil than what you put in your gearbox. Your gearbox on your machines will take a 220 or a 320. But the lubricate number 8 goes into your thrust bearing here, and your thrust bearing up on top of your Pugmill as well. Here, Jim, you can see we have a 90 extruder, and this main auger shaft radial thrust bearing, it suggests every 8 hours, 1.25 gallons capacity, and that's located right there where we were looking just a second ago.
Where do you get those charts?
If you need some of these charts, we can email them to you electronically. A lot of people have them in their JC Steele ordering charts or their IOL and M manuals.
George, just for your information, Acme does keep these on the U-drive, so if people need to access them, they can get to them pretty quick.
Oh, that's a good idea. That's a real good idea. Well, as we're moving down, Mike, I noticed you have an automatic greaser. One thing that most people will think is that they got an automatic greaser, they don't have to worry about it anymore. But really, you should check it from time to time to make sure that it's working properly, that your lines are not clogged, and that grease is actually making it to the bearings where you want it to go. Now, I did notice, Mike, up on your jumbo Pugmill, you don't have an automatic greaser up there. How do your guys grease that?
Oh, George, what we do is we bring all of our lines into one central location, and we use what's called a greasing manifold, similar to what we got here. It'll just have grease zerks lined up, and they'll manually grease it. But every grease zerk's brought into one location where they don't have to go looking, because there's so many, they can't overlook one and not know. Especially a new operator, he would forget where they were. So we bring them all to one central location, just like this.
That's a good idea.
In our sight glass a while ago, we wasn't running, and it was about full. Where should it be under normal operating conditions?
Well, when the machine is running, your level of oil in the sight glass will drop low because it's being pumped and circulated through the system. So while the machine is at rest is the time to check this. When it's running, it does you no good to really check it. So it's one of those things you should check first thing in the morning before you start. And as you can see, you've got lines running. Anywhere you have a line running, you have a bearing. So your oil is being pumped through the system, down some sight glasses, into the bearings. Like this particular plate here is not a bearing. There's no line going to it. This is just an inspection cover. If we were to pull this off and look inside, you'd be able to see your pump and your plumbing going up and out. Same thing with these other sight covers, or sight covers. There's no line running to it, there's no bearing, so you can pull those off and look inside as well.
What about our bend caps? Is it important to have a good bend cap, or can we just plug those?
No, don't plug those. If you plug them, because the machine warms up, it'll create a positive pressure. And because of that positive pressure, you may cause oil to start seeping past gaskets or past seals. So you want to have a good set of vents like you have up there. I see you've got a filtration system on your oil, and it's good to keep the needle on the valve in the green. If it goes up into the red, that's an indication that it's plugged full of dirt and that it's time to replace.
Should we stick to the changing the oil schedule, or should we just use the gauge?
I would stick to the schedule. Gauges don't always work 100% of the time, and it's better to have good clean oil in the machine.
Good advice. What's the best way to check our bearings to make sure that we're doing everything correctly?
Mike, having a heat gun, temperature gun is a great way to check your bearings. Anywhere you have a line run is where you're getting oil to a bearing. So you've got your rear, main, auger shaft bearing in the gearbox, and you've got your intermediate shaft rear bearing here. So what you want to do is just shoot all the way around it and see what you get. And then it's not a bad idea to check in the middle. And why I do that is because if your key breaks in your coupler, it's possible for that shaft to move rear and actually rub on this cover plate. And if this cover plate is hot, that's a key indicator that something's going on, something's wrong. But hopefully you could hear something going on before you come back here and notice that this is hot. Now you can also check your pulley bearing on the front side of the gearbox, the tail stand bearing, your front intermediate shaft bearing, your front main auger shaft bearing. You can check your thrust pot, and the best thing to do is record all these temperatures for your records. So if you checked it on this day, record your ambient temperature, record your bearing temperatures, and do it like maybe once every few weeks, and then compare it to the last time. So if you ever think you got a hot bearing or you think you're hearing something, you can go back in your records, look at it, and say, well, 3 weeks ago I checked it and it was running the same temperature, so it's probably okay. But if it's 30 degrees hotter than it was and the ambient temperature is the same, that could be a warning sign that something's going on with that bearing. So you may want to look into it.
That's the way we can get it scheduled to prepare.
Right.
So the old hand test coming up here and touching it is not a good indicator.
Well, it's better to be able to have numbers that you can look at in the past, yeah, and have a good record.
Okay. George, what are some things we need to look at on the vacuum on a daily basis?
Well, before you start up, the best thing to do is to drain the water out of the lower tank. If you stop overnight, the water and the oil will separate. The oil will rise to the top and the water to the bottom. So a lot of people will have a drain plug on the bottom of their tank. Yours, I see, is over here. So you'll open that valve, drain the water out until you start to see oil come out, and then close it back off. And you may need to add a little bit of oil to bring your oil level in your sight glass up to about 3/4 or so. Another thing to watch for, Mike, is to ensure that your cooler is working properly. Your cooler is basically like a big radiator, and you have a pump that pumps the oil out of the lower tank into the lower section of the cooler, up, out, and into your upper tank. Now the way I like to do it, Mike, is take another reading on my temperature gun, and your motor pumping the oil out should be hotter than the oil coming in. So you've got about 8 degrees, and that's pretty good. Most of the time you see between 7 to 10, so you're about 8 degrees cool, so you know it's working. You also want to watch to make sure that there's no dirt that will plug up the airflow through the cooler. If it's full of dirt, then it's not getting air passed through it, and it won't be doing its job as efficiently. The other thing is to make sure that your fan is running, and you've got another motor up here that turns your fan to pull cool air through. And it's best to have these coolers in a place that's away from a dusty environment. Some people have them underneath a conveyor belt, and a lot of times the dirt will fall down off the belt onto the cooler and then plug it up. But yours is completely away from your belts in another room, so that's nice to see. Another thing that I like to check is the temperatures of the tanks. And like here at the bottom, we're reading about 100 degrees, and then as we move up, it warms up. So if you see a low temperature on the bottom, you may have some buildup in the bottom of your tank, and that buildup's taking the place of where maybe some oil should be. So your sight glass may read 3/4, but if your tank is 1/4 of the way full of sludge or dirt, then it may be time to clean it out. And I noticed you had a large plug on the other side to where you could open it and pull any kind of buildup out. Another thing that a lot of people will have on their vacuum systems, Mike, that you don't have is a inline filter system, and that also aids in keeping the fluid cool going to your, clean going to your pump. And as we look at your pump here, you'll see you've got a shaft coming from your motor. Now that shaft has a take-up gland with packing on it. You'll want to see it drip oil, maybe about 4 drips a minute or so. If it's coming out too much, it may overflow and it'll create a messy situation. If you don't have enough oil though, then it could cause your pump to heat up, and I've even seen where they get so hot that it may be smoking because it doesn't have enough lubrication. This is a good thing to have also, is a vacuum gauge here. That way you know what your pump is in good condition, and it's pulling almost a complete vacuum, almost down to 30. I mean, that's as good as you can get. Up here, you'll notice you have a one-way check valve, and sometimes you may hear it clatter a little bit. But what that does is it's pulling the vacuum down, and you'll see the arrow. The vacuum's coming into your pump. Now, if this doesn't work and your operators turn the vacuum pump off before they turn or release the pressure on their vacuum chamber, it may actually pull oil up into the system. So this one-way valve should help prevent that. Down here at the bottom, we looked at where you drain your oil, but you also have the capability to add another valve if you chose to do so. I'll just shine a light on it. There's a spot where you could put a valve and some plumbing if you wanted to drain it out here to the side. I think a lot of people have it set up like that, but yours works the same way. Mike, what kind of oil are you using in your vacuum system?
Most Acme plants run a transformer oil. They add a red dye to it so we can separate and know the difference with the operator, but when he's separating the water from the oil. When that red hits it, he knows to stop. He's drained enough for everyday operation.
Very good.
George, are there any new tools or anything that's existing that may be out there to make our jobs easier?
JC Steele offers a auger pulling tool. They've got a shank removal tool, and they also offer a aluminum vacuum chamber lid that's much lighter, and a lot of the operators really like that since it's significantly lighter. They also offer a digital absolute vacuum pressure gauge, and that makes it a little bit easier for some operators to read to know what vacuum they have. Mike, I'd like to thank you for having me out here. I enjoyed talking with you, and I hope everything we did today was helpful.
We appreciate you coming out here. I know it's going to be helpful to a lot of new operators. There'll be a lot of things I learned today. Thank you.
Thank you. Jim, I'd like to talk a little bit about extrusion safety. Here, George Winter, the manufacturing supervisor, has an extrusion safety paper up that tells you some things that you should not do. If the extruder auger shaft is turning and there is no clay coming out of your die, that is a bad situation. What can happen is you can build up steam inside the barrel of the extruder, and that steam turned into pressure could cause a very dangerous situation. It could cause the shear pin to fail, and that could result into pin fragments and the door opening quickly. The die holder studs could be compromised. And basically what causes that is dry material in front of wet material. If you have wet clay will not push dry clay, so you always want to make sure that you have no dry clay in front of the wet clay. If that situation does happen, what you want to do is open the door, run the material out until it comes to a consistency and a moisture content that you know it will run out of your machine. Even if that involves running out enough material that you're confident that you will not have a problem, that's the best thing to do, even if you have to open up the door and dig it out. Once you get it dug out and cleaned out, then you can go ahead and shut the door back and start to make brick again. But it's very important that you don't try to run wet clay behind dry clay. Also, you want to make sure that all your guards are in place and that they're serviceable. You don't want to have a guard that is in bad condition. If you have a guard that's in bad condition, it could create a hazard, possibly more dangerous than what you're trying to guard it from. Testing. I'm here with Mike Mannery. Mike, how you doing today?
Pretty good.
Anything else you got to say? Take two. Take 200.